Every AI model is just a fancy database query. Okay, what do I mean by this? So there's this website. It's called the Library of Babel, and in it basically has kind of like an index of every single possible sequence of words. Okay, you kind of like imagine just like randomly generated word, like characters. Okay, you just put all of it into a database. Every sort of length of text you can imagine, well, up to a finite number because they only store so much, right, is stored in this database. This means that everything, so like the text you sent your mom, love poems you might have written to somebody, those hateful comments you left on someone's Instagram profile, all of that is kind of like inside here because it's just all text ever written up to a certain number of characters. Now let's like think of this in the abstract. So let's think about an infinite database, or you can think just some very large finite number, about as large as an AI response would be. This could include all kinds of, it could include valid Python code. It could also include invalid Python code that could maybe run but has some errors. So all of this text is inside of this. Okay, what we can kind of think of like a large language model is doing is basically just providing a very efficient indexing, or all we can think of an LLM doing is providing a kind of fuzzy indexing. So what do I mean by fuzzy indexing? And basically you can ask for a particular block of text by just kind of describing what's inside of it. It's not entirely accurate. You're not doing like a pattern match on words, right? You're just trying to say, you have an input, you have an output, and then it's trying to find the closest kind of block of text that just matches what you've input. Like, this is kind of effectively what AIs are doing. If we really want to think about this, we want to think about LLMs mathematically, right? You need to think about, okay, these are functions that take in an input and take in an output. What are these? Inputs are strings of characters, right? They're a sequence of characters. The output is also a sequence of characters. They live in this mathematical world of all of these characters, right? And then what you're doing is you're just trying to basically do a model that takes an input and then sort of spits out a neighborhood, like the probability of landing on a correct answer, or a probability distribution around elements in this space that have this answer, right? And that's effectively what we've trained. We've trained a very efficient text querying system. So where am I going with this? Well, the point I'm going with this is that truth doesn't really matter in this context. Like, truth was never baked in to the model. Yeah, we can have the model maybe we can try to train it on true statements, right? But that doesn't mean that it's going to match all true statements, right? It's just going to effectively learn how to match certain kinds of text to other kinds of text. It's trying to find the closest thing inside of a neighborhood of familiar text, right? And the way it does this is through vector embeddings and similarity scores and all this sort of stuff. But the point is that's effectively what it's doing. And the way it does this is by constructing this text character by character. So we kind of sample and then sort of keep drawing. We kind of sample the closest character, and then we kind of get the next closest character and this sort of thing. So if we want to talk about whether or not AI output is true or not, well, we first even have to ask ourselves that's even a good question, because like inside of what an AI is trained to do, truth is irrelevant. It's just learning how to efficiently query this very large database of all text ever written. Well, up to with certain kinds of characters and up to certain sort of things, right? And anyone who knows about how AI works and how AI trains, like if you understand the universal approximation theorem, you understand exactly what I'm talking about here with like what the AI is doing when it's learning effectively. Because all you're doing is you're basically just kind of matching, outputs with some fuzzy criteria based on inputs. That's all that these models do. That's all that all machine learning models do. All that we've done is just turn the inputs and outputs into all text. We had these kinds of models before. Of course, like before transformers took over, we had RNNs. They had the same sort of function signature. They just weren't as good. They just weren't as good. Transformers gave us a way of querying this whole thing more efficiently. But the thing is, they still didn't give us truth. They still didn't give us a way of providing the correct answer all the time, because being correct and being true isn't just a function from A to B, right? Okay, so I just want to elaborate a little bit more on kind of what I meant from a mathematical perspective. So in machine learning, when we're specifying a model, okay, a model M, we're basically trying to emulate a function. So I have a function and it has its inputs x, has its outputs y. Okay. And this model is going to have this exact same function signature. So now let's let L be just the English. Okay, this is the English language. All right. And this is, and we can think of this as like all sort of random sentences that are created from, just characters and words in the English language, right? Just, you can sort of spill them out. Proper, well-formatted English grammar is going to come out just naturally, kind of like randomly in these sorts of areas, okay? And when I create a test database, right? I am effectively specifying a function, which is like the inputs and then the outputs. These are like the question that you're asking the AI, and then this is the expected output. Okay, and then the AI is just trying to learn this function from x to y, and in this case, it just becomes a function from all these random characters to all these random characters. But it's informed by this testing, but it's informed by all this sort of testing that you've done. And this is what I mean when I say that these are effectively just database lookups, because you can think of L as just being a database that contains all of the characters ever written in any sequence, and then all I'm doing is I'm finding a very efficient way, that's informed from other previous examples. I'm just trying to find a very efficient way to get the closest looking piece of the English language that looks like it comes at it would be the most related to the prompt that I give it. And that's really all these things are learning, right? They're just kind of matching what the most likely text is that matches your query effectively, and you're basically just querying text. You might as well just be asking it, give me the text that solves this problem or that describes the solution to this problem, and that's just kind of all that it's doing. Anyways, that's why I think AI is basically just a fancy querying engine, isn't really capable of creating true statements consistently, and why you shouldn't trust it too. If you want to hear me talk more about AI and these sorts of topics, just let me know. Like this video, subscribe, and see you in the next one.